Jai Hind to all. My name is Babita. I am assistant professor in MCA department at Akgec Engineering College, Ghaziabad. So today we are coming with a new lecture in the series of computer network, and this is the second lecture. And this lecture and topic is derived from the syllabus of the MCA students, and the semester is third, and the code is BMC 303. So basically, this is very important concept, and in which we are learn about the topology. And here we have a network topology. So let's start to this concept. The outcome of this lecture, the learner will definitely learn about the what do you mean by the topology? Yeah, what is the concept of the topology? Yeah, you can say the network topology. And next we will talk about some types of the topology. And here we have a different kinds of topology in which we are mainly focusing on the concept of a physical topology. So next we will discuss some advantages and disadvantages of each kind of topology, right? So let's start. So before going into the depth of the topic, let's understand the concept of topology. What do you mean by topology? The first question is arise when we are working on this topic. The network topology is the process in which we are arranging some kind of devices. Let's say the device may be a mobile, your laptop, or you have some other like Bluetooth, right? Watch. So that's type of devices. If I'm arranging in a particular, in a systematic manner, and we make connection between all devices, and this particular configuration and this particular process is called the topology. So topology is nothing but it is the arrangement of devices and connection between all devices in a computer network. So why it is important? Because whenever we are working on any topic, first of all, we come to know about what is the importance in our life of this topic, right? So if I am talking about the topology, so what is the reason why that's why we are studying this topic, and what is the main purpose? Yeah, what are the importance of this topic? That's why we have to work on this, right? So choosing the right topology, because topology provide a configuration and topology provide a arrangement of the device. Let's take an example. If I have the 100 devices and I have to connect with all in an efficient manner, so how can we connect? That's the process is going a seamless, or you can say the communication part, because why we are making the network? We are making a network for sharing the information and to communicate with each other. So basically, whenever we are designing and whenever we are configuring different kinds of devices into a one approach, or you can say in a one network, so basically choosing the right topology is important, because it affects the performance, cost, reliability and security of the network. Because a particular network is perform well, or you can say that it is a cost effective, or it is a reliable, we can answer these questions by applying a right topology of the network, right? So if I'm talking about the importance, so it provides the efficient data communication, because if I'm designing or I'm arranging the all devices betterly, so my communication is become efficient, right? The data transfer activity is become seamless and smoothly. Next, it will improve the network performance, because if I am sending 100 packets at a time, so basically what it happen here, we are transferring much data at a moment, or you can say per second. So it improve the network performance. In the network performance, we will consider the throughput mainly, ki how much data we will send a particular minute, right? Next, it will improve the it will make the reliability and fault tolerance easy, because the data is surely received by the receiver at in the duration in which we are transferring. So it will ensure the reliability and fault tolerance. That means if the configuration of the devices is just maintainable, that we will able to find the fault where it will occur, right? So that's why also important for us. Next, it will improve the scalability and expansion. Like if I'm I have the concept ki at the time of the requirement, at the time of execution, I will define, I will able to expand or able to remove the particular devices from the network. So it will make the efficient or it make the easy to scalability and expansion of the network, right? And next we will talk about the cost effectiveness, because the configuration is very cost, you can say that it requires some cost, because we are using different kinds of wires, and we can say the lots of wires to make a connections between the all devices. So how much it will be effective, that depends on the configuration approach, ki, what type of wires requirement here, and how much wires we will require to connect the all devices, right? So it will also ensure the cost effectiveness of the network. Next, it will talk about the security. And the security also a one concern during the configuration of a network, or you can say about the network. Whenever we are designing a network, the first concern of the network designer is the security. यानी कि हमारा जो network है have a much ability to secure the all transmission or secure the communication between the senders and the receivers. So these are the importance. That's why we are using that's why we are studying in this topic. Let's talk about the types of the topology. So topology here we have broadly classified into two categories. First one is a logical topology, and next one is physical topology. So basically today's concern is a physical topology, because we are talking about the configuration, or we are talking about the designing concept. That's why I'm just talking about the physical topology. I'm not talking about the logical. Logical is just relate to the transmission way. You can say the what type of scenario, what type of approach I will use to transfer the data from one place to another place, right? So that type of configuration and that type of approach will be considered in the logical topology. In physical topology, that is the individual designing phase of the devices, right? So here we have a first topology, that is very simple topology, P2P topology. What do you mean by the P2P topology? That is a point-to-point topology, in which here simply have a sender and receiver. Sender sends data. Let's discuss with the explanation. Point-to-point topology, that is the type of topology that works on the functionality of a sender and receiver. What do you mean by the functionality of sender and receiver? Let's take an example. Here we have a sender and here we have a receiver, right? Sender simply sends the message and receiver, here sender sends the message and receiver receive the message. Same as receiver sends the message and sender only receive the message. So at a one time it will implement only one function. This is the kind of topology, we can say, in which devices are connected in a one-to-one manner. At a time, only sender sends the message and the next moment receiver receive the message, right? So at a one time, only one functionality is performed. That's mean we are saying it as a at a one time, that is a half duplex mode. It will work in a half duplex mode. Next, we will talk about the bus topology. So basically the bus topology, as its name implies, what do you mean by the bus? Let's take an example. Here we have a bus, and in which we have a two rows, like that's type of sheets, as you familiar with this concept. In a bus, here we have a sheet 1, sheet 2, sheet 2, right? Same as in a bus topology, the network is designed in the same manner. Here we have a device 1, device 2, device 3, and device 4, device 5, and all device connecting to this particular cable. And this cable is working as a medium for transferring the data. Let's take an example. I'm sending a one packet on this particular medium, that is maybe a that may be a cable, that may be a any particular dedicated path between the all devices, and this particular message is a travel on this medium, and the device 1, device 2, and device 3, all device can access can have the authorized to for example, the message is traveling for all devices, but only the device will accept of the message which is intended for that, right? So बेसिकली व्हाट आई एम सेइंग, मैं ये कहना चाह रही हूँ कि मैसेज सभी डिवाइसेस के पास ट्रेवल करेगा, बट एग्जैक्टली उस मैसेज को एक्सेप्ट कौन करेगा? जिस पर्टिकुलर डिवाइस के लिए उसको सेंड किया गया है, दैट इज द इंटेंडेड रिसीवर ऑफ दैट message. So in a bus topology, data transmission follows broadcast communication. What do you mean by कि all devices के पास वो हमारा data share हो रहा है या travel कर रहा है? तो that means I am broadcasting the message, everyone will listen, right? But accept the message only for this for that user. जैसे for example in a class I am sharing a one concept, I am sharing some information, all the students will listen, but exactly I am asking a question to a particular student, so answer only give that student, right? सभी ने क्वेश्चन सुना, बट आंसर कौन सा स्टूडेंट करेगा? जिसको मैं इंस्ट्रक्ट कर रही हूँ. जैसे फॉर एग्जाम्पल आई एम सेइंग कि आकाश यू विल टेल अबाउट द नेटवर्क, सो answer will given by the intended student. So this is the concept in which the message is broadcast, but फिर you can say the answer will given by the intended receiver, the message will received by the intended receiver, right? So this is the concept of bus topology. So means frame are propagated to all the nodes, but only the intended receiver received the message or processed the data. So problem is this, although this topology is very simple because the configuration is very simple, right? And the transmission process is very simple, and less requirement of the cable, because as you seen here, only one cable is required to connect the more than one devices, right? So it is very simple topology and very cost effective, but what is the problem by using this topology? So as the number of nodes increase, let's say कि here in this configuration I am extending I am expand the devices from 100 devices to 1000 devices. So what happened here? There will be leading the performance degradation or maybe the chance of collision. So this is the main problem by using this topology. Next we will talk about the star topology. So here basically, as its name implies, star topology. What do you just for example कि आपने यहाँ पे कुछ particular devices रखे हुए, right? And all the device connect with each other. You can say no, this is not the configuration. Let's say here we have the concept, and all the device will connect these particular center point. So in the star topology, all the device connecting to a single hub and through a cable. So this is particular center, and this center is nothing but it is a hub, or it can be a switch through which all the remaining device will connect to make the communication, right? So this is the configuration of the star topology, in which we have a center, or you can say the centralized node, that will handle the all sharing, or that will handle the all information that stored at the center node, right? So in this, as you see here, what is the benefits or what is the drawback of using this topology? Here we have a center hub. Let's say this center hub fail or have some errors, so all the communication will shut down. This is the main problem of using this topology. The central device act as a single point of failure, because making the redundancy essential in an enterprise network. Another drawback of using this topology, because all the data will store at this center point, or here we have, let's say the information is sharing by this particular node, and the same information is sharing by this particular node, and the duplicacy of the same message will store at the center hub, right? Next, we will talk about the ring topology. So basically, it is very easy, and you may consider it is a single path, right? What is the purpose of ring? Let's say here we have a one dedicated connection or one dedicated medium to connect all the devices. Devices are present around this particular ring, right? Because in which we have a हमारे पास starting point होगा, and this starting point is further connecting to the ending point is further connecting to the starting point. So this is the concept of a ring topology, in which connecting a closed loop. This is the concept of closed loop. That means the starting point is connecting further by the ending point, right? And the data is transmitted sequentially from one node to another node, right? In a ring topology, token, because let's take an example कि all more than one devices simultaneously attempts the transmission on the medium. So what is the problem? Let's say this particular device also attempt, and this particular device also attempt the same time, at the same time. So what happened here? The transmission is traveling from this side or either this side. So what is this? Here we have the congestion, because the both devices attempt at the same time. So what happened here? The collision will occur, right? So data flows in a one direction, but it can be made bidirectional by using dually ring, right? Yeah, we have two connections between each network node. That is called a dually ring topology, right? Yeah, dual ring topology. Next, we will talk about the mesh topology. So mesh topology establishes multiple point-to-point links. What do you mean by mesh? You easily not find what device is connecting to different type of devices, in which we have a mesh up. Let's say I am having 4 devices, right? So this particular device is connecting to this device, and this is also connecting to this device, and this is also connecting to this device. Same as this device is connecting to this device, and this device, and this device. Same as this device is connecting to this, and this. So this is the mesh topology, in which we have a multiple path to reach that particular node. As you see, in a bus topology, having only single path to reach from one place to another place. In a star topology, having a one path from center to particular node, from center to particular node. In a ring topology, also have a single path to reach at the destination. But in a mesh topology, we have a multiple path or multiple links to send the data at a particular node. So enabling path redundancy and high fault tolerance. Let's take, here we have a problem. So there is the benefit कि my transmission will not stop, because I have a 2 alternate path through which I can continue my transmission. So let's take a common example कि internet backbone where various internet service providers are connecting to each other via dedicated links. Another example is a mesh topology used in the military communication system. Yeah, you can say in a aircraft navigation system. So this is mesh topology, and this more beneficial in the large areas or large systems. Next, we have the tree topology. As its name implies, we are making a tree type structure in which we have a one center node and further some child node, right? So this type of configuration is considered as a tree topology, in which we are working in a hierarchical manner. Hierarchical, that means we have a one root and then it will divide it further, and this particular node is further divided into sub nodes. So combining the characteristic of a star and bus topology, it will support structured growth and widely used in a large scale organizations, right? So basically the configuration of a tree type topology is this, in which we have making one particular node, and this particular node is connecting further to another two nodes, and this particular node is further connecting to other nodes, right? So let's take an example, this particular bus topology and this particular star topology, in which we have a center hub or some other nodes that are connecting to each other, and one node that is centralized work is considered as a hub, right? So in a switch case, yeah, you can say the two layer switch cases work for this purpose, right? The problem of this topology is a failure of a higher level that will be considered as a hub node. Yeah, you can say the centralized node. So if this particular node become fail or become have the fault, so the undergoing communication process will stop automatically if this particular node have the issues, connection issues, right? So next we have the hybrid topology. So hybrid, the name is combination of two, right? So hybrid topology integrates two or more topologies to meet specific performance, scalability and reliability requirements. Whenever we are talking about a hybrid, so hybrid is the combination of two things, right? One particular, then plus two particular, then plus three particular. So that type of communication is always considered as a hybrid. So in which we are combining, we are joining more than two types of topology, because we are talking about the hybrid topology. So I am talking about the more than one combination of the topology types, right? So it is an important common topology in a modern enterprise or campus network. If I'm taking about the example of the university campus, so here we have the same approach, because in some departments we are talking about, we are implementing bus topology. In some departments we are implementing star topology, and overall I am talking about the university campus. So basically it make the hybrid topology infrastructures, right? So basically what is the importance? It require the careful planning, advanced monitoring and skilled network administrators, because to work over the more than one topologies, combination of topologies. So basically here we have a well planned configuration or well planned scenarios in which we are connecting the devices to each other, right? So this is the concept of topology, and we are talking about the some advantage or drawbacks. So this is the topic for today, and this topic is more beneficial for the MCA second year students. And with all that content, I will stop my lecture. Thank you so much.